Hi there, this is Eugene Blanchard, and this is Basic Electricity for Bent Brains. We're going to talk about definitions. We're going to get through definitions of the basic characteristics of electricity. We'll talk about charge, voltage, power, current, and resistance. Now, something I got to tell you, that everything I tell you is a lie. Now, the reason for this is that I'm not going to go through the chemistry and the physics and the traditional way of talking about this. So I'm just going to go through and talk about kind of like a real life explanation of the electrical characteristics. Very first one we're going to talk about is charge. The symbol is Q. The units are coulombs. 1 coulomb is 6.24 times 10 to the 18 electrons. That's a lot of electrons. So an example, 10 to the third power is 1,000 electrons. 10 to the sixth power is 1,000,000 electrons. 10 to the ninth power is 1,000,000,000 electrons. 10 to the 12th power is 1,000,000,000,000. We're talking about 10 to the 18th power of electrons. That's a lot of electrons. So we need a lot of electrons to do anything. Voltage, the symbol is V. The units are volts. That makes it kind of easy. The definition, the potential work required to move a charge. Sometimes we'll talk about it as a pressure. You know, there's a pressure for to move a charge. 1 volt is equal to 1 joule of work required to move 1 coulomb. So you need 1 joule of work to move 1 coulomb. When you have that, you have 1 volt. So if we wanted to move a coulomb of charge from point A to point B, how much work is required to move it? And we call that voltage, right? And it's called the potential difference. So in order to move electrically from point A to point B, there has to be an electrical or a potential difference. And the voltage is the pressure that's going to move the electrons at point A to point B. Power, the symbol is P. Units are watts, and it's the work moved over time. So 1 watt is equal to 1 joule over 1 second. A joule, now remember this, a volt is the joules to move 1 coulomb. So really we're talking about the voltage to move 1 coulomb over a second. So power is, we have our voltage, which is just kind of pressure, it's static, it's a potential energy that's required to move a coulomb. And now we're actually moving it. Now we have power because we have the time factor. We're going to move this over a period of time. Power, how much energy joules is used over a period of time. So basically, I've got this pressure, a voltage that's being applied to the electrons, and I'm moving it. And now we're going to time it, and that becomes power. Now this is interesting. Current is the symbol I. The units are amps or ampere. Typically we shorten it to amps. Definition, the flow of electrons over time. So 1 amp is equal to 1 coulomb over 1 second. So we're going to move, if you move 6.24 times 10 to the 18th electrons over 1 second, that's equivalent to, that's the definition of 1 amp. So current, how fast are the electrons moving? So here we're having our bucket of 1 coulomb of electrons, 6.24 times 10 to the 18th, and we've got this voltage, this pressure on it, and we're moving it. As soon as we start moving it, we have a time factor, and then we're looking at the individual electrons. So we can have a bucket, let's say, here's a really good example. We have a really strong guy, he's able to pick up that bucket and move it from point A to point B in 10 seconds, right? So we're going to say he moves it. And that will give us our 1 coulomb over 10 second current rating. Right? Now, if you had a smaller guy, he can't lift the whole bucket up, so he has to divide it into 5 trips. So he has to take 5 trips in 10 seconds. So in order to do 5 trips in 10 seconds, he's got to be at least 5 times faster than the big guy. So the electrons are moving faster with the small guy because he has to take smaller loads more quicker, more often than the big guy who takes 1 load and he just takes 10 seconds and sort of saunters over there. So we can have the same power and the same voltage that says, yeah, we're going to move a coulomb of electrons from one point A to point B, but then we might find that the speed of the electrons is going to be different. Resistance, symbol R, is ohms, and we'll also use the omega symbol shown here. The definition, it's opposition to the flow of current. And what it does is says, how difficult is it for the electrons to move? Is it easy or difficult for electrons to move? Right? So here we have a path where the electrons are going to flow, and is there a lot of friction, electrical friction, that's slowing the electrons down, or is it very conductive, easy to move? Let's do a quick summary. We're going to summarize our charge, voltage, power, current, and resistance. Charge, symbol Q, units are coulombs. 1 coulomb is 6.24 times 10 to 18 electrons, right? So when we have a bucket full of electrons, there will be 1 coulomb in them, and they'll have 6.24 times 10 to 18 electrons. Voltage, it's called the potential difference. It's the pressure, or how much work is required to move from point A to point B. It's a potential difference, which means that nothing is going to happen. It's just saying that in order to go from point A to point B, we need this much work or this much pressure. Power, how much energy is used over a period of time. How much voltage is used over a period of time to move a certain amount of electrons, right? So we're going to say, we're going to take these electrons and we got our pressure, and now we're starting to move them. We have something happen, and as we move it, we're going to time it, and that's going to give us our power. Current, how fast are the electrons moving? We talked before how a big guy can take the bucket and just saunter up in 10 seconds, and the electrons are moving at that sauntering slow rate. Or a little guy would have to divide it up into 5 buckets, and in order to do it in 10 seconds, he's got to run back and forth, right? So he's going to be running a lot faster. Electrons are going to be moving faster. In the end, all the electrons are going to get to the destination, but they're just going to be moving at different speeds. Resistance, is it easy or difficult for electrons to move, right? So we're going to look at the media, or the path it's going to take, and we're going to see, is it easy? There's some materials that are easy for electrons to move through. We call them conductors, and then there's some materials that are difficult to move through, and we call them resistors. Let's do an analogy. We're going to push a bucket of electrons up a hill from point A to point B. Voltage, the difference in height, is the amount of work needed. So we're going to say we're going to push it up this hill, and it's going to require pressure as we push this, and that's how much pressure we need to get it to go. And we also call it potential difference. Power is how quickly we move the bucket using the voltage we have. So we've got our pressure going, it starts to move, now we're timing it. Current, how fast are the electrons moving, or how fast are we going up, right? No problem there. We talked about that with the big guy and the little guy. Resistance, what type of path are we using? Is it a steep hill, right? If it's a steep hill, it's going to restrict the electron movement, because now we've got to push up this steep hill. It's going to be harder to push. What if it's a gentle hill, a gentle slope? Well, that's going to be easier to push or slide that bucket up than a steep hill, right? So what type of path are we using? So that gives you a sort of basic electricity fundamentals for bent brains. I hope this helps you. Thank you very much for watching.